Okay, guys, hello. I hope I'm audible. Can someone confirm in the chat? Cool, great. Then, okay, then we'll start in few minutes. Okay, let's wait for others to join. So just open Google Collab. Just search Google Collab in Google. Okay. So how we would be going about this session is, I have a content that I have prepared. Okay. This is an NLP, so we'll start with the introduction of NLP and understand what NLP is. But on the side, meanwhile, we will also be trying to maintain our notebook. Okay, Google Colab notebook will be maintaining, which will have the basics of NLP ready in that. Okay, so that you can refer to the code as well. And in the end, I have a presentation. Okay, so throughout this session for today's, we'll go about the presentation, and in the end, I'll share the presentation with you as well. Okay, right. So that is how we go about. And let me share my other screen, which is a presentation. And okay, so I hope my screen is visible with the presentation. And in order to reply why, yes or no, you can just write y or n, because sometimes I need your uh, need your input, so that just to understand whether you are getting the things or not, or whether should I repeat, or what more we should change. Cool. So yeah, let's start then. And today it's 5th November. We are at 11 a.m. It's a session from 11 to 1. We'll try to take a 5-minute break if needed, right? And yeah, thank you, Ram, for sharing your LinkedIn with me, and others. You can also share if we can connect on LinkedIn as well. Cool. Okay, you can share with everyone. If someone wants to share with everyone, they're open to do that. Yeah. Okay, then let's start with NLP. What NLP is, it's natural language processing. Meanwhile, if you have any doubts, I have kept everyone on mute, so that no disturbing sound from anyone else, like from the background, may enter and can't disturb our concentration on the work. Okay, so if in case, but that shouldn't stop you from asking. So if in case you want to ask anything, you can just write in the chat. Okay, I'll answer that. If that is something which I'm going to take in few minutes, or in the session, so I might skip that, but in the end, if that is not covered, you can just again ping me that. Okay, so that is one thing. Second thing is, if you want to speak, you can just raise your hand, and I'll see on the window that I have opened. So I am using a split screen, as you can see, and on one side I have your chats and everything open, and on the other screen I have a presentation. So that's the thing. And so when you raise your hand, I'll ask you to I'll unmute you, and we can discuss on that topic. Okay, if you want. Cool. So that is how we go about. And without wasting more time, let's start with NLP. Okay, so again, welcome everyone. So these are the topics that we are going to cover in day one. We'll start with evolution of human language. What is NLP applications, its components, process and demo, and then interview preparation and resources and Q&A. So we'll try to wrap this up in day one, that is today itself. And on the day two, we'll build a complete NLP project from scratch. Okay, that's the target from day one and day two. Okay, there is a one small requirement of that you should be a good. So how much experience are you in terms of regular expression? Because I think most of you are passed out. So you must have an idea of the regular expressions. So how many of you have an idea of regular expression? You can write Y or N in the chat. That would be helpful for me. So guys, for all those people who have just joined, we are just about to start the session. So if you have joined at the correct time, so you have not missed anything. Ayush has an experience. Okay, seems like everyone has experience, because 4 or 5 people have responded in the private chat as well. So seems like everyone has a experience in regular expression. Just know what regular expressions are and can handle that, right? Cool, thanks. So for everyone who have joined, We will these are the topics that we'll cover in day one, and this is the topic that we'll cover in day two. So we'll try to wrap this up in day one. If anything remains, like resource interview preparation or something, we can shift it to day two, and then we can have an LP project. So there is a lot of scope in day two as well. Cool. Anything you want to ask, the chat is always open to you. You can type me in the private, you can type me in the public. Okay, you can raise your hand, I will ask and mute you. And yeah, then knew something about redirection, that would be more than enough. Also, I'll we would require that tomorrow, so I'll send you a link so that if every one of you can dedicate some of your important and valuable time on rejects, that would be really add and value to your profile, to your project. So I'll send you the proper link, and yeah, if you can go through, that would be really great. Otherwise, with your little knowledge, I think that would be more than enough for what we require to tomorrow. Just you should know in regular expression that how to create a string of which contains some characters, some particular characters, how to replace few things. So that is all we require, right? Okay, cool then. Uh, let's start with day one. Okay, that is evolution of human language. And anything you want to ask, chat is open for you. Cool. Then, so without any further delay, let's have a look at the agenda that we have already seen. Now we'll move to, yeah, evolution of human language. So the success of the human race is because of our ability to communicate, right? That's it. That is information sharing. Using this ability, we have marched ahead of other animals and have become the most sophisticated creatures. And this is what differentiates us among all the other animals. We begin to look for. So we begin to look for ways to preserve our thoughts and feelings and messages, all those things, and other information. We started with oral communication first, like other animals do right now as well. But because of its informal nature, we begin painting on the walls and caves. Right? You have must have seen Ajanta caves and all those things. You must have seen, right, in like in real life or in somewhere in Google something, right? Where we are, where we live now, there was a need to standardize the drawing so that everyone could understand, and that's where the concept of developing a language came. Okay. However, such many such standards came up, resulting in many languages, with each language have its own basic sets of alphabets, combinations of alphabets, okay, which are known as words, and the combination of words which which were arranged meaningfully, which became the sentence now, right? Each language has a set of rules based on words and are combined to form these sentences, right? These rules that we name as are called grammar, right? And now I'm not going to take any more time in explaining you guys about grammar and all, right? Now, coming to today's world, according to the industry estimates, only 21 of the available data is present in the structured form, right? Data is being generated as we spoke, as I am speaking there. The Zoom is recording this call, I know, and there might be someone who is taking, there is an option of transcript as well. So my voice is being converted to a text data, and this has been stored in the structured form, right? But only 21% of that available data is present in the structured form, and and it's being generated as we speak, right? Or as we tweet, or as we send message on WhatsApp, let's say Instagram or Facebook Messenger, okay, and various other platforms, okay. But majority of the data exists in the textual form, okay, which is highly unstructured, right, in nature. Now, in order to produce significant and actionable insight from this data, it is important for us to get acquainted with the techniques and the principle of natural language processing, that we call as NLP in short. Okay, so let's move on. So let's understand what exactly is NLP now. So natural language processing refers to artificial intelligence method communicating with an intelligent system using natural language. Okay, now it is a part of computer science and artificial intelligence that basically deals with human language by utilizing NLP and its component. One can organize a massive chunk of text data, Okay, perform numerous automated tasks and solve a wide range of problems, right? Such as automation, summarization, okay, machine translation, named entity recognition, all those that you can see on the left side of your screen. I'm just going through that. Okay, now we'll learn about all these later in the video, right, or in this session, right? Now the goal here is to process, I would rather say understand the natural language in order to perform some useful task, right? Like making appointment, okay, buying things, spell checking, generating responses, social media monitoring, all those stuff we'll try to do from in this session, right? So now, if you look at the various applications of NLP in the industry, firstly, we have spell checking, which is usually there in, if you can find it mostly in words or the documents readers, right? Even online also you can check, you can go through the spell checking, right? Now, now we have words, keyword search, and it is also a field where NLP is heavily used, right? Now, extracting information from websites or particular documents also require the knowledge of NLP. And one of the coolest application of NLP is the address matching, address in matching, which is basically recommendation of the ads based on your search. Okay, what it does, it analyzes the text of the data which you are already using or searched and matched it with the text data of the advertisement. Like you must have seen, and this has been a controversy from quite years, like the problem that uh, Google has with it, Google Assistant, and there is always a saying that Google is listing everything. You can take this experiment as well. You can sit with 2 3 friends, or you can sit with your family in a closed room, and you can talk about a particular topic. Let's say you want to buy furniture, so you can talk about the furniture in the room for, let's say, 10 15 minutes. And when you open some public website which has ads, like maybe a news website or maybe some coding website which has ads on it, right? And header or a footer or sides layout, it has ads. So it is very high chances that you will see the ads of the furniture, of buying a furniture, maybe Pepperfry or some other company, it may come pop up, right? Or Amazon, something, right? So that's where we say that Google is listing everything. There you can find the videos on internet. So I'm exactly not sure, and I won't comment whether they are listening or not, but there are videos mentioning these things, right? So you can check on YouTube as well. So yeah, that's one thing. And now sentimental analysis is also a very major part of NLP. And other application is speak ignition. uh, here we also here we are also talking about the voice assistant like Siri, Google Assistant, uh, Cortana. Okay. Also we need to thank Apple for creating the first voice assistant, that is Siri now, right? We have the implementation of the chatbots. Most of you guys must have used the customer chat services provided in various apps. Like most of these apps use the chatbot, which in itself uses the NLP to process the data, uh, then provide a response based on the input. That is also an application of NLP. Now another application of NLP is machine translation. Most common example is Google Translate. As you know, you now it uses NLP to translate the data, okay, or I would say a text from one language to another language, and that too in the real time. So it has helped us. It might, you might have used that stuff as well, right? Okay, I hope everything is crisp and clear till now. It's all theory that we need to pass, and once we are back on the track with the examples and the coding part, then where the starting part, the interesting part starts. Okay, cool. Now let's see the components of NLP. So NLP basically consists of two components. One is NLG and another is NLU. So NLG is natural language generation, NLU is natural language understanding. Okay, let's move on. So Now understanding the natural language involves mapping the given input in natural language into the useful representation and analyzing different aspects of the language. We'll see what it exactly means, how it means in the code form of code and everything. Moving on to NLG, it involves mapping the given input in the natural language into some sorry, yeah. So natural language NLG, yeah, NLG is the process of let's say producing meaningful phrases and sentences in the form of natural language from some internal representation, right? Now it involves text planning, which include retrieving the relevant content from the knowledge base. Okay, it also involves sentence planning, which include choosing required words from the meaningful phrases. Okay, setting tone of the sentence, and finally we have text realization. It is basically mapping sentence plan into a sentence structure. Okay, we'll learn more about this NLG and NLU using the code, so don't worry about that. Now, Uh, so that was a bit of theory part and what definitions we require, what the base we require for going ahead in the NLP. Now let us see what type of ambiguities we face. So usually natural language understanding, which is NLU, right, is much harder than NLG. Now you might be thinking that even a small child can understand a language, right? So how come it is so easy for human beings and it is so easy and it is so difficult for the computer to process it, right? That's what my statement is, that NLU is much harder than NLG. Like generation is easier but understanding of it is harder. And so let's understand what the difficulties that a machine faces while understanding a language. So in natural language understanding, there are certain ambiguities which as you can see on your screen are lexical ambiguity, syntactical ambiguity, referential ambiguity. Now understanding a language is very hard. Taking our English into consideration, there are a lot of ambiguities, and that too at a different level. So let's start with lexical ambiguity then. So lexical ambiguity is the presence of the two or more possible meanings with a single word within a single word basically. Okay, it is also called semantic ambiguity. For example, let's consider the following sentence and let's focus on the italicized rules, right? So the sentence goes like this: she is looking for a match. Okay, so what do you think, what do you infer from this particular line, guys? So is she looking for a match, like as in a match of something, football or cricket, something like that, or is he looking for some partner for like dating match or something like that? So it's not clear from the sentence, right? Now other example, let's take another example, that is the fisherman went to the bank. So is it the bank that deposits our money, okay, that we opens account in, or is it some water bank that a fisherman might go to catch some fish, or to like his boat must be standing there. Oh, so these are the type of ambiguities you can see and you can understand. These are the lexical ambiguities that are English language and we have uh, in terms of NLP, and there the problem is starts. Now, syntactical ambiguity is in English grammar. This ambiguity is the presence of two or more possible meanings within a single sentence or a sequence of words. Okay, it is called structure ambiguity or grammatical ambiguity. You can see. Now let's have a look at these sentences. So the sentence goes like, the chicken is ready to eat. Okay, so is the chicken ready for us to eat, or so this is a kind of, or is it, or the chicken is ready to eat something, right? Now a single sentence can have two meanings, right? Both the meanings may be correct depending upon environment to environment and situation to situation, right? The machine does not know these things exactly, so that's comes the ambiguity for the machine, right? uh, the other example can be I saw the man with the binoculars. So the two meanings of this particular statement can be, was the man having binoculars? Like I saw a man with binoculars, so the man was having, the binoculars, or I saw a man with my own binoculars. So these are the two meanings that this particular sentence can go into. Okay, now coming to the third ambiguity, referential ambiguity, which arises when we refer to something using pronouns. Now, let's say, let's take this example. The boy told his father the theft. Okay, he was very upset, right? So this is a statement. Now, when we talk about he was very upset, so if you focus on the italicized word, he, does this mean that the boy was upset or the thief was upset? Okay, or the father was upset? Nobody knows. This is a, nobody knows, right? So this is called a referential ambiguity. Who he is referring to, basically, he, boy, father, or the thief, right? It's not clear. Cool, guys. I think this ambiguity part is clear as well, right? And you can write anytime in the chat if you think, if you feel anything is not, you need, should I repeat anything or anything like that, you can just write in the chat. Okay, then move to slide 10. Now, when we process text, okay, there are few terminologies that we need to understand. So the first terminology that we are going to talk about is tokenization. So let's understand to what tokenization is. So it's basically a process of breaking up strings into small tokens, okay, which in turn are small structure or unit or words, right, that can be used for tokenization, right. It involves three steps: breaking a complex sentence into words, right, understanding the importance of each of the words, right, and yeah, understanding the importance of each of the word with respect to the sentence, or produce a structural description on an input sentence, right. So, so if we take the sentence today, we'll understand tokenization. So let's take the first five tokens. Yeah. So let's not go to example first. Let's open the notepad, notebook basically. Okay. So I would request you to so I would request you to open the Google Colab in your Google. Just type Google Colab in your Google and you can open. Okay, you can, I hope my screen is visible and you can look into that. I have just searched Google Colab, and we have to click on the first link, that is collab.research.google.com, right? Just open that and just let me know in the chat if everything till now is clear, and if everything till now is clear. This is also a presentation. This is also a notebook that I've kept open. Okay, so it will open something like this. Okay, I have just renamed my notebook. Okay, so you can rename it from here. Okay, nothing else. I'm closing this. Okay, so it will open something like this, right? Exactly like this, to be specific. Guys, let me know in the chat if you have opened it, or let me know in type Y or N. Like if Y, if you are coding with us on the live, like on the live class, so that I can get an idea and I can wait for some time for you to type. If you are not coding with us, like on the live, you are just watching the video, you can type Y no in the chat, and so that I get an idea how many people are there. Yeah. So why? Mostly it's why, guys. We have 20 people. It would be great if many of you can reply. Yeah, cool. Thank you. Thank you, Ayush, Vaishnavi, everyone. Yeah, it's okay then for to see the video as well. Yeah, and you can try it at your own pace when you get the recording or something. I'll share you the document, although this complete notebook I'll share with you, and also the presentation that I'm showing you. Both the things I'll share with you. So don't worry about taking the notes and all that stuff. Just focus on understanding. Have this for everyone. Yeah. Cool. Cool then. Uh, yeah. So just give me a minute. I'll. Okay, so I hope everyone has opened the Google Colab. So this is a basically online platform. Okay, it has a server with Google, connected with Google, and if you click on this run button, anything you can write your Python code or any code. Okay, and if you click on the run button, starting few commands will take time. Okay, in order to the kernel gets connected and everything. Okay, and once initial few commands are done, the platform becomes super fast, right? So once the what the code you have written is successfully executed, the green tick will something like this will appear. Okay, otherwise it would be a red tick, red one, right? And the error would appear below. Okay, in order to add cells, these are called cells. In order to add more cells, you can just click here, or you can press control MB, control plus M plus B. Okay, now in order to run these cells, you need to click on this run button, or you can press control enter, whichever suits you, right? So this is all about the Google Colab notebooks. Okay, if in case you are using some, if you are familiar with Jupyter, if you are familiar with Spider, Anaconda, or anything VS Code, you can use that. The code will remain exactly the same, but you need to check on the installation and setting up the environment part, that you have to take care from your side, right? Here it does not require such stuff, so that's why Google Colab is becomes an easy option. There is also a option to download the file, so I can download the file and I can send you once the session ends, right? Cool, then let's start. So guys, there would be few things that would be very theoretical, okay, and that are very specific to NLP. Okay, so please bear with that. Please bear me with on that. Okay, Aditya, you can rejoin. Try rejoining, because I think my voice is a bit clear with everyone else. So that's the thing, Aditya. Cool, cool then. So let's import first few libraries first. So there is NLTK library that we will use, that will have most of the functions of NLP, right? So we'll import that after this. So import OS, import uh, NLTK. There is a corpus, we'll import that. So nltk.corpus, import that. Okay, now let's run and check whether they are getting executed. Okay, they are successfully getting imported. If in case you face any issue that NLTK is not installed or downloaded, you can just type the command pip installed NLTK, pip install nltk.corpus, something like that. Whichever library is not you are facing a difficulty with. Cool. That is what we needed to import. Now there is a term called corpus, which can be defined as a collection of text documents, right? Uh, it can be it can be thought as just as a bunch of text files in a directory. Okay, or often alongside with many other directories of text files. Okay, they are basically a collection of text files, you can say corpus. Okay, that's what we have imported as well. So now we'll download few text files out of that. Okay, so one text file is so this is the method nltk dot download. Download is the function that you would that we would require to download any corpus. So there are few names of corpus like Brown, Gutenberg. Okay, uh, so these are the some names of the corpus. So uh, let me download the Gutenberg. Okay, so you can Google it. They are just the names of the corpus. Nothing logic. No logic. It's just the name of the corpus. You can just Google the name of the corpuses in NLTK, and you will get tons of names, and you can use them. So I'm just using another already defined inbuilt text file. That is what I'm using. Right now, if in order I want to see what are the words that are stored in Gutenberg. So what I can do is I can just write Gutenberg dot words. Words is the function that will help us. Um, Gutenberg is not defined. Okay, so let's import the brown first then. So nltk dot brown. Let's go for brown then. That might have Gutenberg inside that. So NLTK dot download brown. Yeah. Now let's import brown as well. So NLTK, once it is downloaded from corpus, we need to import that. So from NLTK dot corpus, import brown, and let's check whether this is working or not. Yeah, it is working. It has been downloaded. Now let's see the words that are stored in brown itself. Brown dot words. This, so these are the words that are stored in. There are a hell lot of words. There is, you can see there are dot dot dots. There are a hell lot of words in brown. Right now, let's download try downloading Gutenberg again. It get downloaded successfully. Let's use the fields. Okay, so there is a term called field IDs. Okay, a field ID is basically a list of the file that make up this corpus, right? So it's basically a list of files that make up this corpus. So corpus is, you can imagine, it's a directory of a file. Okay, and field IDs are the list of that files. Let's say I want to see the list of the files for the Gutenberg. So what I can do is NLTK dot corpus Gutenberg dot file IDs. Look, these are the file IDs that we have. Okay, so you can see there are text, they are in the form of dot text extension. Okay, so let's try to use some text files now. Okay, so let's look into, you have to choose one of those files. Okay, so let's choose this Shakespeare Hamlet. Okay, so we'll choose that. So let me define a variable with the name Hamlet. Any name you can choose. Hamlet seems to be more appropriate at this point. So NLTK dot corpus dot Gutenberg dot words. We have seen that till now we have already used dot word keyword. We have used it. It gives us all the words that are inside that. So we want the words inside which text file. So we want it inside the Shakespeare's Hamlet. So I copy this name. I paste it here, and now let's print the Hamlet. What we are getting. Let's print that. As you can. Oh, corpus. It must be. Yeah, as you can see, there are hell lot of words in Shakespeare's Hamlet, right? In .txt file, there are hell lot of words, starting with bracket, the tragedy of Hamlet by. There are hell lot of words. Okay, so uh, let's look at the first 500 words, let's say, of this textual paragraph. So I'll write a for loop for words in Hamlet, and I'll slice first 500. I only want the first 500 words, so I'm using the slice operation. And let's print the, let's say, words, and let's separate the words by a space, and let's end the word by let's say comma, or let's say space itself. Now let's run that. You can see these are the first 500 words. Guys, any issue till now? Anything, anyone, anything? We have not started with tokenization. It's just basics that I am explaining you. uh okay, okay, yeah, yeah, I have, sure. Yeah. Mohammed. So what is meant by brown? Yeah, so brown basically it's a corpus. Okay, as I told you that corpus. What's the starting command? Yeah, this is the starting command, I guess. NLTK dot download brown, right? Yeah. So corpus. Hmm. Corpus are basically defined as a collection of the text documents. Okay, as we take out Shakespeare, Hamlet, and all those things. So they are basically the combination. Okay, collection or combination of the text documents. Okay. or it can be just thought as a like a just a bunch of text files in a directory. Okay, you can think of it's already inbuilt, we have nothing to do with it. Okay, they are already inbuilt and we are just importing it and then does downloading and seeing their words. Okay, and downloading a sub part of them and just printing them. Okay, just we are doing that stuff, right? Cool. Okay, anyone else, guys? Everything is clear, you can just type a yes, why, or yes, that would be very great. Everyone? Yeah. Okay, cool, great, thank you. And yeah, then okay, so yeah, okay, Abhishek, this till now it's fine. We have imported everything. We have seen what NLTK has, what NLTK feature does. They have already inbuilt all those things. So yeah, we are good as of now. But what's next? So what we can do is we can just Google data science, data CINC, data science. We can Google it and let's see. I don't want courses or all those things. So let's go with Wikipedia and yeah. So what we'll do is we'll copy this text, right? Let's copy the first paragraph of it. Would that be enough? That's what I'm thinking. Okay, let's take two paragraphs then. We need some variables now. So let's take two paragraphs. And what we can do is I'll send you in the chat as well what two paragraphs I have taken so that you can get the same results for what I'm getting. Okay, now in these two paragraphs, we can assign, let's make a variable name with the name DS. Okay, and I'll assign them in the string. I'll assign them in a string and oh my god. Yeah. Now you can see they have I have defined them as a string. I've done nothing. I have just taken a string, random string from the internet, and I have given it the value as DS. Right. You can just copy it as well. I have sent you in the chat. Right. So let us see what the type of DS is. DS is. Okay, DS is not defined. I have to run that. Now if I run it. str, that is a string, so it's a type of string. Then our work is done now. So what we will do with this string is we will first tokenize it, we'll break it into parts, we'll then go about cleaning this part. Okay, so we go about doing all this stuff. So let's start with that now. So so there is a sub module or sub library, you can say, with the name tokenize. Okay, so from that there is a important sub module which is called word tokenize. So let's import that. So from nltk dot tokenize, I'll import word underscore tokenize. Okay. Now let's there is another corpus which is called punk, punkt, punkt. So let's download that. So nltk dot download. These are the names of the corpus. You can just Google it and you will find tons of corpus. I am just using what I remember. Okay. And so what specifically about punk is punk tokenizer basically divides a text into a list of sentences. Okay, by using let's say unsupervised learning algorithm. Okay, to build a model for let's say abbreviation words. Okay, and the words that start sentences, all that stuff. So that's why I'm putting punk it specifically. But for playing with there are a hell lot of corpus that you can play with and you can find their values as well. So let's involve punct here. Let's run that. It run successfully here. Yeah, perfect. Now let's tokenize that. So there is a function called word tokenize, right? So let's define a variable ds underscore tokens. So ds is a string that we want to tokenize, right? So these are the ds underscore tokens will contain all the tokens of the word ds. Okay, so let's see how to tokenize that. So word underscore tokenize is the keyword, is the function, and we have to pass the string inside this. And after this, I'll print ds underscore tokens in the next line. So let's run this. Let's run this. And now you can see the complete string has been converted into the tokens. Guys, got the idea? This is how we tokenize a particular word, and these are the tokens: data, sciences, and comma, square brackets, one, two, three, all the stuff, all that stuff that in any string is called, in the string is called a token. Okay, a big token, small token, doesn't matter, right? Okay, now I don't count, I can count them manually. So let's use a function called len to count the total number of tokens. So len is the function we would use that for. So len underscore tokens. So it will give us 201 is the length of the tokens that we have, right? Now, now let's check the frequency of each token. I can see there are many words that are repeating, right? Like brackets are repeating. Data is the most common word that is repeating. Science is repeating. Is that, and these words are is repeating. Okay. So let's see. Let's with is repeating. So let's see how many times a particular word is appearing. So let's see the frequency of each token. So for that, what we can do is there is a submodule again, which is called probability submodule. And in this, there is a very important submodule which is called frequency distribution. Okay, so we'll import that. So let's try importing that. So from NLTK dot probability, we need to import frequency distribution of fric dict distribution, and let's create an object for that. Frequency distribution for frequency freq. Yeah, q it is dict. Probability. Yeah, sorry, my bad. It would be NL. Uh, cannot import freq dic. Oh, not dis. Dict distribution. Okay, here I have to change again. Small mistakes. Yeah. Cool. Finally, it's successfully executed and successfully done. So what it basically returns, this frequency distribution, what we have created this. So dist is basically an empty string, and what we'll do is we'll store the count of each word in this. Okay. So but it's not a ordinary dictionary. You can't take any other ordinary dictionary. It's a special dictionary. It has many functions. It has many variables that we'll use in the coming cells, right? Okay, so let's try to create a function that will count that. Okay, so what we'll do is we'll go through a run for loop. We'll run a for loop, and what I will do is let's first check that. So I will go through each of the words in the DS token. I'll go through each of the word: field, that, users, scientific, methods, comma, brackets, one, two, three, all those words. I'll go through each of the word. And what I will do is since I can see there are two different words. One is data with capital D, and there is another data with small d, like this. And then there is a data with capital D, then there is a data with small d. But I know these two words are same, right? Cap D with capital D and small d will not make us any difference in terms of NLP when NLP is considered, right? So it's only increasing our computation cost. So what I will do is I also, they are not separate words, so I can't count them as a separate word as well in NLP. So what I want is I want to create a dictionary that will have something like, I'll show you on a whiteboard what I want to do. So here you can see what we'll do is we'll create a dictionary. This is a dictionary that we have. Okay. And in this dictionary, let's say there is a word coming called data. So I'll store data, and as the key, this is called key, right? And as the value, what I will store is the number of count. Let's say it is appearing 10 times in this particular string. What is string? DS string. Okay. And this is the count that I will store. The how many times this particular word is getting stored. Okay. Before that, I want to convert capital word data into small word, like the uppercase into a lowercase. That is what I want to do, right? Lowercase are already like the lowercase. I'll count them directly, right? So that is what I want to do first, and then I will. So initially, this dictionary contains everything in an empty. Like this dictionary is empty. So any word I give to it will have a value as 0, right? If in case I print the value of at this point, if I print the value of any word in this dictionary, it would be 0 because this dictionary is empty, right, guys? So I need to increase the counter whenever I encounter a particular word. Let's say what I'm saying is, let's say I have the words like on the screen itself, ts tokens, right? I have a word data, then sign, then is, then n. Okay, then so I what I will do is I will write something like uh, let's say of dictionary of data. Okay, initially it is assigned to 0, so I will write plus equals to 1. So whenever I encounter the word data, I will do this operation so that it will increase the count of the word data. Okay, it gives the count or the frequency of the data word, right? So that is what I will do. So let's try to like try over it. So let me define a variable with the name word. Okay, so for word in ds underscore tokens, right, we have to go through each word in the ds underscore token, and in that what I have to, there is a dictionary fdist, and in that I have to store this word. Okay, I'll store that word. I'll like increment it as equals to 1. I'll increment whenever it appears, and whenever that particular words appear, and yeah, that's it, I guess, right? But that's not enough. We have to convert the word into the lowercase, as we have discussed. I want to convert that word into the lowercase as well, right? So f dot lowercase is the function for that. Okay, cool. No, not lowercase. We want the function is lower. Yeah. So let's run it and let's see whether, yeah, it's running successfully. So let's see how the dictionary looks like. And you can see the comma is coming 16 times, and is coming 13 times, data is coming 12 times, science is coming 11 times, the square bracket 7 times, closing bracket 7 times. So all these things are coming as many times as you can see. Cool, guys. So this is how you can create, you can count the words, how many words are coming when at what times. Okay, how many times. Cool. So that is, once that is done, we I think we are good. So what we can do next is, let's count. Let's, if you want to check the count of any word, let's say I want to check if I want to check the count of the word sign. So I will write fdist, and I'll write see, and if I run it, it will return 11, right? Because the count of the word science is 11. Yeah. So it will return that. So any word you want to check the count of, you can check just that. Now let's see, since we have converted every word to a lowercase, and now let's see how many tokens we have reduced to. So we'll print the length of uh, f dist, and let's see how many words we have reduced to. Okay, so now it's 101. So initially, if you remember, there were 201 tokens, and now it has been reduced to 101. So that's what the duplicates things. Okay, we still need to work on the data, because the data is not perfect, because it has square bracket, it has comma. So please understand, in the terms of NLP, do you think any significance a square bracket or a 1 or 2 in such form, that is it written in the data, in the data, our current data, would make any sense, and would help us in terms of understanding the language or generation of the language? Okay, it would only make our word difficult. right? Yeah, that's really interesting. And once we go about this now, it the things will getting interesting. And believe me, by the end of tomorrow's class, you will have a very good project. I'll disclose. Let me disclose the name of the project on that part. That is called Twitter sentimental analysis. And so again, all those buzz that is going on around Twitter, so I thought this topic would be a good. And also uh, I thought of, because the crypto market is going down as the day passes by. So as far as I know, my knowledge of things are being considered. So I have thought to keep the word as crypto, the main keyword where we can get the tweets from, it would be the crypto. So let's do that tomorrow, and we'll analyze the tweets. We'll analyze whether the tweets are getting positive, negative, or neutral. What are the types of the tweet? We'll try to plot those beautiful graphs as well, which will help us analyzing the tweets, and we can have and save them, right? So let's do all that stuff. So yeah, cool then. So that's the length of the dictionary average that we have reduced to. Now let's see uh, what are the 10 most common tokens in the data science in this DS token list, or in the string. What are the 10 most common words, right? So I'll create a variable with this fdist underscore top 10. Okay. And for that I'll use in order to get this, sorry, would be underscore, yeah. So in order to get this, I'll use the function called most common. So fdist dot most common, most underscore common. This is an inbuilt function, and how many most common we want? Top 10 most common words we want. So fdist underscore top 10. Let's print that and let's see how what we are getting the result. Okay, so as you can all, we have already seen like comma and data science. These were the words. So top 10 words, top 5 words, top 3 words you can get from this with the help of this, right? So it's very easy to get that. Okay, right. So now there is another concept that we need to learn, and that we need to see in this uh, tokenization domain. That is how to blank line the tokenize. That is a blank line tokenizer is a tokenizer that will use that divides a string into the substrings, right, by treating any sequence of the blank line as a separator. For example, that there in the data that we have taken, in the string that we have taken, there are two paragraphs. Okay, that means there is one line breaker in between. So we want to return, let's say in the paragraph you want to return how many line breakers are there. Okay, so in order to get that, what we'll do is there is a tokenizer which is called blank line tokenizer. Okay, so let's import that first and let's use that. So from nltk dot tokenize, uh, we'll import what we need to import, that is blank line underscore to tokenize, right? And let's tokenize, let's use it on the ds. Okay, so blank underscore ds underscore blank is the new variable that I'm making, and I'll use this function, use the function of it, sorry, as pass ds in it. Cool. And yeah, it had been tokenized. Now I'll print the length of the ds underscore blank, so it will give me the number of line breakers we have. As you can see, there are two, like there are two paragraphs in that. Cool. So yeah, that was all for what we have for the tokenize, and I'll stop sharing my screen. We'll go back to PPT and let's quickly get there. How fast this operation will be run on the huge text files in real time. Uh yeah, mm, that I'm not sure, because that depends upon the data, that depends upon the inbuilt computing power of these worlds and the library. So you can check that on the internet, I guess, because if you want the exact time, all these operations are pretty fast, depending upon the GPU you are getting, the system configurations you will use, but they are pretty fast because they are all are inbuilt and they have already been trained on that. So yeah, that's the thing. So yeah, let me share my window of presentation. Yeah. Okay, guys, let's get back to the slide as well. Now, now coming back to our tokenization part, we have bigrams, trigrams, n-grams. Okay. Now bigrams are the basically the tokens of two consecutive written words. As you can see on the right, it's already mentioned. Okay. And similarly, the trigrams are referred to as the tokens of three consecutive written words, and usually the n-gram is referred to as a token of any n number of consecutive words for n numbers, right? So let's see how we can implement the same using analytical libraries for bigram, trigrams, and n-grams. Okay, let's go back to the notebook again. And yeah, so now let's start with importing. There is a util function that bigram, trigrams, and n-grams, some modules are stored in. So let's import that. So from nltk dot util, we will import bigrams, diagrams, and n-grams. Okay, so let's try to run that. Okay. Okay, it's n-grams. Typos, typos all around. Yeah. So it has been successfully imported. Now, what we'll do is we'll take a random string, okay, and we'll tokenize it. Okay. So let's take a random string, and I already had an example. Uh, okay, so I'll paste that in the chat, and you can copy that from here. And yeah, that's a string you can take in for the example. It gives the best combination of other words, so that's why I have already kept that. Okay, so string equals to and okay guys, then let's create a variable with the name. So it's a quote kind of thing, right? So let's create a variable with the name quotes underscore tokens, because we are going to tokenize it and we would break it into the tokens. So nltk dot, we know now how to tokenize the words, guys, right? uh, we have already done that using the words underscore token function. So I'll copy that and I'll paste it here as well. Word tokenize, and yeah, what we want to tokenize, we want to tokenize the string, the string with the name string, right? Now let's tokenize first. Yeah, it has been successfully tokenized. Now let's see what the tokens are. You can see it, the most beautiful things in the world cannot be seen. Okay, they have been tokenized and they have been tokenized into single words. Now comes the interesting part, and that's why we have jumped to the notebook. That is creating a diagram of these tokens, of those tokens, right? Okay, let's create the diagram then. So let me define a variable with the name quotes underscore diagrams, and I want to convert what the function I will use is nltk dot bigrams is the function that I will use, and what bigrams, what whose bigram I want to make. So quotes token, the name of the token that I want to create the bigrams of. Okay, this would I want it to be in the form of list, so I'll convert this in the list. Done. Now in order to print that, I'll copy this and paste it here. I'll get an answer. Okay, you can see the all the tokens have been combined with the two tokens. Now they are not more single anymore, they have been combined. Cool. So these are called bigrams because the tokens have been combined to two. Now the same code will go for trigrams, so I'll copy that code, why to write it again and again, and the same code will go for n-gram as well. So let's first do it for trigram. So trigram, only the spelling of that will change. Here it will change, the function will change, and here the spelling will change. The rest everything will remain same. You can see that they are now the diagrams. Okay. Now let's hear about the n-grams. N-grams, the spelling will change. There is also one thing that will change. In case of buy and try, uh, it's already clearly visible, and that the what's the number of the tokens, the collection of the tokens we want. In case of buy, we want 2. In case of try, we want 3. But what in case of n? So we have to specify the value of n. So there we can pass a second paragraph. That's why n-gram function comes with a second parameter where we have to pass the value of the n. So that's the thing. So we can take the value of n as 5. Let's say, for example, you can take it anything, 5, 10, 15, anything. In the case of 5, therefore 5 words have been getting combined as a single token. Cool, guys. So that is what bigram, trigram, and n-gram is. And let me know in the chat if everything seems good for you till now. If your understanding is any improvement you want, anything you want to share. Cool. Cool with everyone. Great. Yeah, we'll show you, Ram. Tomorrow we'll make a project on it, and on real time, in the class itself, I show you how we analyze that whether the tweets last. Let's say we'll take around 1,000 tweets last live active 1,000 tweets on the Twitter. Are they positive, negative, or neutral? That are about crypto, about layoff, about job, about hiring, anything you want to take topic of, right? So we'll take a random topic and we'll do that. Cool. Just wait for building of these basics because it would be required, right? Cool. Great, guys. Can we take a small 5 minutes break? I've been speaking for like more than an hour now. So I have kept my I'll kept I'll stop sharing my screen and we can take a quick 5 minutes break and we'll be back at 12:15. Cool. Cool, guys. It's 12, 10, 12, 11 in my clock, and yeah, thank you. We'll be at 12:15 back, and once you are back you can have some water if you want. Cool, then it seems like everyone else is back, so yeah, let's start again where we left. So I hope my screen is visible for that, in that case. Cool, then. Yeah, yeah, let's start then from where we left. The n-grams and trigrams, bigrams we have covered, right? Cool. So let's take this example, and now if you can see, this is stemming. Yeah, yeah, yeah. So now once we have got all the words, or as I say, the tokens, we need to make some changes to the tokens, and for that we have a process called stemming. Now, okay, what stemming does is normalize the words into its base root form. Okay, so if you look at the words where, just give me a second. Okay, yeah. So all these words, as you can see, all these words are originate from a single root word, that is affect. And now stemming algorithm works by cutting off end or beginning of the words and taking into account a list of common prefixes and suffixes that can be found in an infected word, right? Now this indiscriminate cutting can be successful in some occasion, but on this other hand, it can lead to, and it has some limitation and can lead to problem as well. Yeah. So yeah, so what we can do now is we can jump onto the notebook again, and let's see how we can uh, go about this stemming as well, right? I hope my screen is visible with the notebook. And yeah, for stemming, what we need, there are different stammers that are used for stemming in today's world, and that are defined in NLTK library specifically. And we are using few stammers at this point, and every stammer has its own limitation. Every stammer has its own way of working, right? So there is a Porter stammer that we start with. So yeah, so let's import that first. So from nltk.stem import Porter stammer, right? And pst, and let me define another object for that. So pst equals to Porter stammer, and let me check whether this works fine. Yeah, it's successfully imported, and we have created an object for that. So it will help us in the stemming now. Okay, so let's stem the word having. Okay, let's take a word. So it's pst dot stem will let's stem the word having, and let's see what output we get. As you can see, it returns its base word, that is have. It's not always necessary that they would return the base case, but in most of the cases they would return. Again, these it depends upon two three things. The training algorithm they have been gone through, the words the words we have chosen. Okay, uh, the stemmer that we are using. So all these things it depends upon. Okay, now let's try it with more number of words. Let's say we pass a list of words. Okay, so words to stem, I would name a variable. Okay, and let's create a list of these words which we want to stem. So let's say give, and giving, and given, and give. Okay, and now what I will do is I will iterate over them and stem them one by one. So let's see how we can do. So words in words to stem. Okay, words is a variable that I've created in words to stem, and let me print after stemming as well. So what I will print is words plus colon, print in this form. Okay, that is what the first was the give will appear and the stem of the give will appear. Giving will appear and the stem of the giving will appear. Okay, so pst dot stem and then write words. Cool, and let's run this and let's see how it goes. Cool, guys. So I think they have given most of the correct words. Like giving is given game, but given it does not give the root word. So again, as I told you, it depends upon word to word. It depends upon the learning data that these algorithms inbuilt have been gone through. So every stammer has its own limitation, has its own advantage and the way of stemming, right? Okay, so let's move on to another stemmer. Let's see another stemmer how it works. So the stemmer that we now see is called Lancaster stemmer. Okay, Lancaster stemmer. So from NLTK dot stemmer dot stem will import what will import is uh, Lancaster Lancaster stemmer. Okay, and let's create an object for that. So lst equals to Lancaster lan stemmer. Let's create a function for that. Let's see if it works fine. Yeah, it works fine. Now I'll do the same thing. Let's take the same example on the Lancaster stemmer and let's see what different Lancaster could have made. Use Lancaster. So I'll just replace it with my object, and you can see it has converted to a more shorter part, right? It is converted to a root word and with the less number of words as well. Cool, guys. So this is how the Lancaster stammer works. Again, they have their own limitation. Might in some cases might this be helpful. In some cases might this be helpful. So again, it depends upon case to case. It depends upon the use case. All those things that we gone through. So it depends upon many things. So we can't just say that this stammer is better. This stammer, that stammer is better. Yeah, that's the thing. Okay, so let's again explore another stammer and let's see how this particular stammer performs. Uh, so from this stammer that we are going to work is called snowball stammer. Okay, this is very important. Most of the cases we use this. We I am also using this for the I would be using this for the next NLP project, the NLP project that we are going to make tomorrow. We'll be using this snowball stammer for that case. So NLTK dot stem, we will import snowball stammer. Yeah, here it is, and I'll copy this because I need to create an object for that, right? But in this case, the one difference is that you have to specify the language that you are writing the code in. Right? You will be using the words for English. I'll specify. I'll try to import that, and it gets successfully imported. And the same code I will repeat here as well. Now the object is what I will change, just like I did for the previous case. SBST would be the object for use for stemming. Okay. Now let's run this and let's see. Okay, it gives almost the same result like this PST, that is Porter stammer is giving. But yeah, it again it depends upon the words. It in some cases they might give the same result. In some cases they might give the different result. So it depends upon words we have chosen in the data basically. So it depends upon data to data. Cool. So that was stemming, guys. Let me know if you have any doubts in that in the comment and in the section. And yeah, we can jump on to our presentation and we can continue what we were doing and move on to the next part we have. Okay, so stemming is what we have covered. Now, very important part is called uh, lemmatization. Lemmatization is basically the groups. What message I got? Okay, so now what lemmatization does is groups together. It groups together different infected forms of the words called lemma. Okay, it is somehow similar to stemming. Okay, as it maps several words into one common root. Now, one thing to keep in consideration is that the output of the lemmatization is a proper word. So, for example, if we look back to our output given by the Lancaster demo, you can see it has given an output give, which is not a word. Like it has given the word give, right? Not with a e, which is not a word. So the output of the lemmatization is a proper word. And for example, if you take lemmatization of gone, going, it all goes into the word go. Now, again, we can see how it works with some examples, and let's try lemmatization using the NLTK library, right? So yeah, let's go back to our notebook as well. So I know it's too much of switching, but that's important really, because learning the theory is not at all sufficient uh, in case of NLP. So that's why we need to switch to. But again, it's theory is also an important part, and it should go side by side. That's the thing. Cool, then lemmatization is what we are going to study. And for lemmatization, there are two libraries, some modules that we need to import, that is wordnet and wordnet lemmatizer. So let's do that. From nltk.stem, we'll import that. So from nltk.stem, we will import mm, wordnet, and from nltk.stem, I'll import wordnet lemmatizer. lematizer, wordnet lematizer. Yeah, that was correct. Yeah. So that's correct. Cool. Now let me create an object for that. So underscore lem be the word for the wordlet wordnet lematizer function. And yeah, the two corpus that I need to download is wordnet and these two. That is I think it was OMW14 1.4. Yeah, 1.4. So let's download that. So nltk dot these are corpus. I told you there is nothing to remember. Whenever you are using the lematizer, you can download them. Okay, that it's just like that. So wordnet and nltk dot download mm, omw dash 1.4. Okay, let's run this. It's finally imported. It's successfully imported. And now let's lematize a few words like let's lematize the same things. Let's take the same example that in this case as well. Instead of sbst, we what we'll use is word underscore lem. Okay, and we are not stemming, we are lemmatizing. Okay, so we change the function lemmatize. Okay, but rest everything will remain the same. Now let's. Okay, you must be worried that it has given the same letter, but because that words were making sense, and shorting them will not were not making sense, so that's why they gave the same result. But again, it depends upon the input to input and the data they have been trained on. Cool. So that, but that's we have to understand the logic behind the lemmatization, and that's what the logic is. And that's how the lemmatization is used. Cool. It's a small topic, not much to worried about. Okay. uh, we have one more important topic upcoming next, that is stop words. After this, yeah, stop words must be there. Yeah. So now, do you know that there are several words in the English language, as we have seen in our data sets as well, that I was talking about in the start of the session. That was close brackets, open brackets, 1 2 3, all those things, comma, full stops, all those things are such words in the English alphabet. mm, like at, for, begin, gone, no. So such various words are thought of as useful in the information of and in the formation of the sentence, right? They are important in formation of sentence, and without it, the sentence won't make any sense. But these words do not really provide any uh, help in terms of NLP. Okay, so these lists of words are called stop words in a language. Okay, and so you might be confused as are they helpful or not. So in the English alphabet, they are helpful, but in terms of NLP, they are not. So NLTK has its own list of stop words that you can use by importing nltk.corpus. Okay, so we'll again jump back to these are some words that are mentioned on our screen that will stop them. Okay, so let's again jump back to the mm, notebook and see what how we can import the stop words and use the stop words. Cool. Yeah. So let's import the stop words first. So from nltk dot corpus, we'll import stop words, and we'll download the stop word as well. We have to download the corpus of stop words. That's why we would be able to access those words, right? Let's see if they are running successfully. Okay, it's corpus. Yeah, successful. And now let's see the types of the words that are in stop words. So if you remember, in the starting few cells we have seen this function, what we call as words, right? In order to see the words that are stored in any particular corpus, we have used this word function called words, right? So we are going to use it again. So stop words dot words. That's how we write, right? But we just have to mention the language we want the stop words for. So there, in our case, we want only for English. So let's mention English. You can see these are the stop words that we can, like, that are already defined in NLTK. These are the stop words. Cool. Yeah, cool then. And what next? Apart from these few words, like apart from the few words in our language, let's move on back to the our own data tokens. Okay, the data sign token that we have already have. Okay, so if you carefully look into this, okay, apart from few words like science, data, interdisciplinary, all these, all the other words are usually stop words, or basically I would say that they do not match any particular word, like special digit. They are like uh, special words like special digit, characters, okay, which do not generally add value in our natural language processing, and hence we should try them to remove them. Okay, now we would try to remove them. Okay, so all those brackets, commas, or all those things, numbers, we'll try to remove them. And here comes the uh, so first let's see what are the first 10 words we have created this variable fdist underscore top 10, right? It's already fine. And you can see these are the words. So comma is unnecessary, this bracket, this is off to, all these are necessary, which does not help us, right? So let's remove that. So here comes the use of the regular expression, right? So a very small use of regular expression, don't need to much worry about that. I'll send you a good article so that you can go through the regular expression part if in case you are not able to understand that. Okay, so let's import the regular expression library, that is regex, we call re in the short, we name it. And let's create a string. So what string I'm going to create? So I'm creating a string that matches any digit or any special character. Okay, so you people who already know the regular expression, they might get an idea. So people who don't know, we just have to mention r, and inside the quotes we have to write the all the special characters that we want to create string of. So basically, let me create that first. So I'll name it as punctuation. Okay, and I'll write re.compile. Right, compile is the function that we generally use for that. And in the compile function, r and then and special words like these. Mm, all the special characters I'm typing of. Then these closing brackets, and then this, and then 0 to 9 close. Okay. So basically, I have created a string with the name punctuation that can match, that will help us in matching with any digit or any special character that you can see on in this string. Okay, so any string or anything we want to match with and take whether they are different or not, because we want to remove them. We want to, that's what I have kept here. That are the special character or digits that I want to remove. Okay, so I'm creating a word with a combination of all those things, right? So let's print the ds tokens. Let's see what they look like. As you can see, these will be removed, 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 these brackets will be removed, right? These square bracket digits, all these things will be removed, right? So let's see that how to remove them. And please be careful, please be uh, please be with me on this, right? Okay. uh, which command, Mohammed? Okay, I think but I don't know which command you are talking about. If you can clarify more, if you want to, if you want me to unmute you, you can raise your hand and I can unmute you as well. Yeah, cool. You can just mention that. I'll take that up. Okay. So yeah, please be careful on that, guys. Everything clear till now? Para 45. Okay. Yeah. Guys, everything clear till now, because we are going to a very important part, and this I need your full concentration on this. So can you type a yes or no if you want me to repeat anything, any doubts, you are aware, you're getting everything, yes or no? Thank you, Ahmad. Yeah. What about others? Yeah, clear. Everyone, cool. Cool then. Let's start then. So, what we are going to do? So, I think you got the idea that we are about to remove the unnecessary words. What are unnecessary words? That contain special character and all those things, from digits and special character, brackets, all those things. We are going to remove from this DS tokens. So you can see the DS token that has contained such type of words at very regular interval, right? And we want to remove such words, okay, because they are not at all helpful in NLP. They are just computing our increasing our computation power by gaining one token from our side, right? So let's remove them. So what I will do is, first I'll create an empty list, okay, and then I will append the words without any punctuation in that string, in that list, okay. Please be careful with that. So let me create a list first. Empty list I'm creating. Post punctuation is the name of the list. Now, what I will do is, please be careful. I will iterate over each word in the DS token. I will iterate over each word. First I will take uh, from the start. First I will take data, then I will take sign, then I will take is, then I will take an interdisciplinary field, that. So I will iterate over each word using a for loop in the DS tokens. Okay. Then I will compare that particular word with the punctuation string, this punctuation string. Okay. And if in case this punctuation string matches with that particular word, okay, I will replace this word in the DS token with an empty string, okay, with an empty character, right? This is my logic. Okay, so let me write the code for that. So for this purpose, for replacing and for comparing, there is a function called sub that we are using. Okay, so let me show you the use for that. So for words in DS underscore tokens, uh, x equals to punctuation dot sub is the function. I'll do an empty character with words. Okay, what I have written, look, iterating over each word in the DS token, iterating over each token with the help of words is the iterator. Words is the iterator. Words will take data, signs, is, square bracket, round bracket, numbers, all these values the word will take. This words variable will take. Now I am comparing all this with the punctuation mark, and if this punctuation mark is matching, okay, I am replacing this particular word from the DS token with an empty string. Okay, why I'm doing that, I'll tell you the logic. And if and that particular word will be returned to X. Let's say if it is an empty string, it is being replaced, so an empty string will be returned to X. Okay, if it is a, let's say, mining, so mining is not a stop word, or mining is not a special character, so X, if they are not matching, so mining will be stored in X. Okay, at time of data will be stored in X. Two will be stored, related will be stored in X. Okay, so all those words will be stored, but special character won't. Special, instead of special character, an empty string will get stored. Okay, that's the logic for this. Now once I am done this, what I will do is, I will push all those words who are not empty inside this list. Okay, so how I will do that? Length of x, if length of x is greater than 0, that they are not empty, then I will append inside this list. So post underscore punctuation dot append x. So I will append those words which are not empty, that are not special characters. Okay, all the special character words were replaced with this empty string, and I'm not pushing the empty string in the post punctuation. So the final list that I have is the post punctuation. Okay, so let me run this, and post punctuation spelling seems to be wrong. Punctuation, I think punctuation is what I have defined. Punctua, punctua. Okay, guys, any mistake you can. Uh, in this line it says punctuation dot sub. Punctuation is not defined. I think I have ran this. Okay, I forgot to run this. Okay, my bad. Now if I run this, look, it's been successful. Now let's print post underscore punctuation. Okay, let's run this. Okay, cool guys. So now if you look at it, a few brackets are still remaining. I don't know why they are remaining. Okay, square brackets I have not removed. I have these square brackets were the part of the regression. They were the part of the this regression expression. So round brackets I was supposed to remove. This colon, semicolon, question mark, dash, all these things, digits, all these were supposed to remove, and they have got removed. So you can see the numbers are not there. Okay, in this post punctuation there are no numbers, there are no round brackets. Okay, only square brackets are remaining now. Yeah, so we can write a different regular expression for removing that. Okay guys, so that is how we removed all the various numbers and digits and all those unnecessary things from the tokens. Now let's get back to our presentation, and let's see what we have next. Okay, so stop words are done. Okay, now we have POS, that is parts of the speech. So parts of the speech, generally speaking, the grammatical type of the words, the verb, the noun, the adjective, adverb, and article. It indicates how a word functions in meaning as well as grammatically, right? Within the sentence, a word can have more than one parts of speech based on the context in which it is used. For example, if we take the sentence, if we take the sentence uh, Google something on internet. Okay, in this particular sentence, Google something on internet. Here Google is used as a verb, right? Although Google, we know it's a proper noun, it's a company, it's organization name, right? So it's a proper noun, but here it has been used as a verb. We can हम कहते हैं ना Google कर लो. So Google कर लो, let Google do the Google, do Google, okay, something like that. So it is expressed as a form of verb rather than a noun. Okay, so these are some type of ambiguities that uh, we generally face while dealing with the NLP problems and the text recognitions. Okay, and so these difficulties makes the natural language understanding even much more harder as compared to natural language generation, as I mentioned, because you understand the language generation is pretty easy. So POS tags are usually need to describe whether a word is a noun, adjective, proper noun, pronoun, singular, plural, word, verb. Okay, it is a symbol, it is an adverb. So as you can see here, we have so many tags on the right hand side of your there is a table, right? So many tags and description for the different kinds of words, all the way from ranging from coordinating conjunction to what work, WRP, right? So as you can see, like what we generally encounter is noun plural, NNP, that is proper noun singular, and verb, WB, VB something, verb will use. Okay, adverb will, yeah, WB, that is verb base form or something like that. Okay, verb third person, all these things will encounter. So basically, let's take an example for that. Now let's So in the first sentence that you can see on the right hand side, the waiter clears the plates from the table. As you can see from the starting, if we use the word takes into consideration, uh, the it is a determiner, right? Now waiter is a noun, cleared is a verb, the is again determiner, the plates are noun, okay, from is not defined, and here the is again the determiner, and the table is again a noun again. And if we take into consideration the sentence on the left hand side of your screen, as you can see, uh, the dog ate the cat similarly, right? So similarly, this is a determiner, the is the determiner, dog is a noun, ate is a verb, and again it's a same determinant and the noun. Cool, guys. I think it's pretty much clear what POS, parts of the speech, does. And let's go get back to the notebook and where we started everything from. And we'll start the POS. That POS is very interesting, I must tell you, that how a language, how a system can tell whether this is a noun, this is a adverb in a regular sentence. So it's very interesting. And the type how they work, and how we are getting everything in natural language processing. So yeah. So POS tagging in LLTK basically is a process to mark up the words in the text format for a particular part of a speech based on its definition and the context. Okay, so all those things the systems try to take into the consideration. So let's see how POS text works. So sent equals to, let's create a variable with the name sent. Okay, uh, let's take this random statement. Timothy is natural when it comes to drawing. Okay, some random sentence we take, and now let's split into tokens. I hope you know how to split into tokens, right? We have been made pro in that, right? Yes. So tokenize now, and what we want to tokenize, send we want to tokenize, and yeah, let's do that. Let's see what send tokens we have. These are the tokens we have as expected. So now we want to the POS tagger that we are going to use is the average perceptron tagger. So let's download that. So nltk dot download average perceptron tagger. Okay. Hmm. Then uh, has defined. So let's use the POS tagger for that. Let's apply the POS tagger. So for token is the name of the variable, and in send tokens I'll iterate over each token in the send tokens, and I'll apply the POS tagger function. So print nltk dot POS tag is the function name of the function, and I'll pass token in that. Like this. This is the closing for this, and this is the closing for this print function. Yeah, cool. Let's run this. And you can see Timoth is a noun, is verb, determiner, natural JJ, when verb again, RPR, verb to RBJ. Okay, cool, guys. I think POS tagger is clear with you. Just simple POS tag is the function that we have to use for POS tagger. Cool, guys. Till now, everything is clear. Yeah, yes. Yeah. Cool. Okay, then we have another topic, a couple of more topics that we are left, and we would be done. Okay, or it would be a good idea to take that tomorrow, because anyway we are not going to complete with that. We have 6 7 more slides that I needed to cover, so it would be a good idea to do that tomorrow, and then we can start with the project. So yeah.